This is part 3 of how to make a magical repair effect in Unity. Today we're going to continue the Unity part we started in part 2. If you want to refresh your memory on that, or haven't seen any of the previous parts so far, then why not pause this video and check them out first. You can find the link to the playlist in the video description. Alright, and now without further ado, have fun with part 3. Now we have come to the finishing touch of our repair effect. We want to add some additional rotation to the animation to make our magical repair effect even more magical. So for that, let's head to our RepairClip. Remember the row objects we created earlier? We're going to use them now to rotate the corresponding pieces around our model's center point. Just FYI, you see here that to rotate the pieces around the up axis, I have to rotate them around Z instead of Y. This is because in Blender Z is up instead of Y like in Unity. Although while we exported our 3D models, we told Blender that for Unity Z is forward and Y is up. But apparently it did not work as I anticipated. Rotating the main parent object around the Y-axis does indeed rotate it around its up-axis, but only because it was rotated by -90 degrees around the X-axis before. If we set it to 0, we see that the main parent object is oriented like in Blender. So basically, our row objects keep their Z-axis as their up-axis, and therefore have to be rotated around Z. Okay, that's it. Now back to where we were before. Let's start with row 1 and have it rotated by 360 degrees during the course of our backwards explosion. For that I'm going to go to where our explosion ends, or more precisely where our rotation will start when we run this clip backwards. So around here. And let's set our rotation to 360, which will automatically add a new animation keyframe here. And let's also delete this keyframe at the end, to not potentially mess up our rotation. Now let's head to the beginning of the explosion. We see that there's already an animation keyframe with our rotation set to 0. So we don't have to add a new one. Now, theoretically, our bottom row should rotate from 0 to 360 degrees when we play our animation clip here, or backwards when we run our project. So let's press play and see how animation has changed now. Not at all. Or nearly not at all. If we look closely, we see that our rotation is kinda indecisive to what to do. First, our value moves up, then goes back to 0, suddenly switches to 360, then goes further down until it realizes that to get to 360 it has to increase its value, and finally ends magically at 360. So why is that? This is because our GameObject recorder apparently uses quaternions for our rotation instead of Euler angles. And when we want to rotate an object, quaternions will always choose the shortest rotation distance. Let me show you an example. Let's say we want to rotate this object around 360 degrees. So we start at position 0 degrees and rotate our object to position 360 degrees. And here we can see the problem. Position 0 degrees and position 360 degrees is basically the same position, as is 720, 1080 and so on. And therefore when we run our project, because our animation clip uses quaternions to rotate our object, Unity is simply speaking confused as to where to go. And here's another example. Let's say we want to rotate our object from 0 to 181 degrees. Unity will rotate the object in the negative direction, because it only has to rotate the object by -179 degrees. So to fix that, all we need to do is to go to our RepairClip, go to row 1 rotation with our mouse pointer, then right click, select interpolation and finally select Euler angles instead of quaternion. And now our rotation works as intended. And if you are asking yourself now what a quaternion is simply speaking a different way to represent rotations. Both Euler angles and quaternions have their pros and cons, but that's a whole other topic. If you're interested in reading more about that topic, I left you some links in the video description. Okay, now let's get back to our magical repair effect. Let's see how our effect looks like now when running our project. Not bad. Now let's also do this for the other rows. And let's see how that looks like now. Okay, this already looks nice. But I want to spice things up a bit. For example, by tweaking some rotations or delaying certain parts of the animation. So I'm going to show you now how I'm going to improve my repair effect here. But feel free to try different things out for yourself, because depending on your model, you may like different changes. So with that out of the way, let's start spicing things up. First, let me shift the keyframes of each row and their child objects, so that each row will start the animation at a different point in time. Next, to get a bit more variation, I'd like one row to rotate 2 times instead of 1. So let's take our top row, row 3, and change the rotation of our keyframe from 360 to 720. And let's also shift the keyframe more to the right so that our top row has a bit more time to rotate. I like it, but I think I have to fine-tune the shifting of each row to make our repairing process look a bit more smoother. And also, let me set the animation speed of our repair clip back to -1 for now. And let's look at our result. Hey, not bad. But there's one last thing I'd like to change. I want our rotation at the end of our repairing process to be slightly faster than it is now. To do that, we have to change the animation curve of each row. So let's start with row 3 by selecting rotation and then select curves. Now here you can see how our rotation value changes during the time the animation clip is played. You can see that our rotation value changes get bigger as we go along our timeline. So the speed of our rotation increases with time. And this is up until it reaches the midpoint of our animation. From here, the speed of our rotation starts to slow down again and gets slower and slower until it reaches the endpoint. So our rotation starts slowly and ends slowly. For the beginning of our repair effect, that's okay, because I want this kind of slow startup, but not for our end. So to change that, all we need to do is to grab this point near our endpoint and slightly drag it up to change the curve and make our rotation value changes a bit more linear towards the end. Great. The changes are subtle, but I like it. Okay, then let's also do this for the other rows. And finally, let's just slightly increase the speed of our repair effect by setting it to -1.25. And let's see how it looks now. Nice. And with that, we've created our magical repair effect. Well, not quite. Visually, we have a nice looking repair effect. But even though our model looks repaired, this model is still the broken model, consisting out of multiple individual broken pieces. So to truly finish our repairing process, we need to swap out our broken pieces with our unhumped model at the end. An easy way to do this is by using animation events. With animation events, we can call functions at specific points in our animation timeline. These functions just need to be in a script attached to our game object that has the animator attached to it. We can use this, for example, to call a function that at the end of our repair effect swaps out our broken model with our unhumped one. So let's do that. In our repair clip, we go to the very beginning of our timeline and add an animation event. And here you can later choose which function you want to call when reaching this point in the timeline. So for that, let's select our broken 3D model game object and give it a script. Let's call it broken 3D model. And in our script, we write a public void replace with unhumped 3D model function that will replace our broken 3D model game object with our unhumped one. To do that, we first need a reference to our unhumped 3D model game object. And then in our function, we first activate our unhumped 3D model and afterwards deactivate our broken 3D model game object. And that's it for our function. Now we just need to head to our animation event and select our new function here. And let's test our project one last time to see the result. We first start our explosion. Then it starts repairing. And as you can see, in the end, our broken 3D model game object gets replaced by our unhumped 3D model game object. And with that, we have finally created our magical repair effect. And because we have our unhumped 3D model back in the end, we can restart our explosion as much as we like without having to restart our project. I hope you liked this video. And if so, why not give it a thumbs up? Do you have some questions or some tips for how to improve this method? Or simply just want to say hello? Then why not write a comment down below? I'd love to hear from you. And thank you so much for watching. And until next time, ciao! Heyo! Thank you all for checking out this tutorial. If you are interested in watching more tutorials or tutorial-like videos, then you can check out this tutorial playlist here. And I don't know what I'm going to put up here, so it's a surprise for us all. What? It's this video? Who would have thought? Alright then, thanks again for watching and have a great day. Bye!